On the 17th of August 1925, an accident occurred at the Neverayon Air Base in the county of Wiltshire. Several Fairey Fawn bombers from the 11th Squadron were taking off as a group. At that moment, on the edge of the airfield stood the prototype of the Westland limousine aircraft. At the controls of this aircraft was Robert Bruce, the director of Westland Aircraft, who had arrived on a visit to the base. One of the bombers, piloted by Pilot Officer Matheson, failed to maintain its course and crashed into the rear of the limousine. Both aircraft were completely destroyed. Fortunately, the pilot and his observer walked away from the crash without a single scratch. As it later turned out, this accident became an unexpected stroke of luck for a group of enthusiast designers from the Westland Company. They happened to need an engine for the aircraft they were developing in their spare time, and building in the company workshop at their own expense in the town of Yeovil in the county of Somerset. It had all begun back in 1924, when a group of engineers set out to create a racing monoplane. Among the members of the project was Tony Fletcher, who had transferred from the Martinside Company. The strength calculations were performed by Harry Edward Medham. The company's test pilot, Major Lawrence Openshaw, supported the team with advice and words of encouragement. The chief designer, Arthur Davenport, who had always loved monoplanes, also gave this project his unofficial approval. The aircraft's design was simple, and in order to save money, hoping that Bruce would allow them to build it, they decided to make it out of wood. It was a semi-braced parasol monoplane with its wing supported by struts. The wing did not taper toward the tips and was built using a box spar and ribs incorporating a Warren truss, a structure with parallel chords and a triangular lattice. The fuselage had a cylindrical monocoque central section to which the engine mount and bracing wires were attached, and the rear section was streamlined in shape, made of frames, stringers, and 4 longerons with cross-bracing struts. When the sketch design was shown to Bruce in January 1925, he studied it carefully and made several changes. He replaced 2 center-section struts with a pair of cantilever struts along the axial line. Bill Widgery, who was responsible for the company's wind tunnel, reported that he had already tested a model in the tunnel. In the following months, more than 60 such tests were conducted, including studying the effect of an operating propeller. Thanks to this work, the wing profile was changed from W4 to the reflexed RAF 34 section. Openshaw proposed using a Rolls-Royce Falcon 3 engine with a power output of 275 horsepower, which had been removed from the wrecked limousine Icars. During the construction of the aircraft, additional tests were carried out to determine which spinner was better, the blunt-ended or the pointed one. In September, when work on the aircraft was in full swing, major structural changes were introduced. During a visit to the Aeroplane and Armament Experimental Establishment at Martlesham Heath in the county of Suffolk, Openshaw saw the metal fuselage frame of the single-seat Hawker Heron fighter. It used steel and duralumin tubes whose ends were flattened into a rectangular cross-section and joined with reinforcing plates and bolts. Quickly realizing the advantages of such a design, Bruce decided to cut away the nose section of the monoplane all the way back to the cockpit and replace it with a structure made of square-section duralumin tubes. Instead of joining the struts directly opposite the longerons, there remained a gap of about 3 millimeters, 0.125 inches, and all loads were transmitted through the reinforcing plates, which were attached to the tubes with rivets instead of bolts. Bruce saw this as a simple way to transition the carpenters to working with metal. The head of the experimental workshop, Fred Rymall, prepared the new nose section of the fuselage in a couple of weeks. It included the engine mount and also carried 2 cross-shaped metal axial struts. This part of the fuselage was covered with metal skinning, while the rest of the fuselage, the wing, and the control surfaces were covered with fabric. The horn-balanced ailerons occupied about 1/4 of the wing's span along the trailing edge. The tail assembly consisted of a small triangular fin with a cutout for the horn balance of the broad-chord rudder, which continued the upward slope of the fin's leading edge, and a strut-braced rectangular tailplane with broad-chord elevators. The streamlined main undercarriage struts were attached at the junction of the forward wing struts and the lower longerons. They had medium-pressure oleo-pneumatic shock absorbers manufactured by Westland. The half axles ran forward from the ends of the central axle to the front part of the engine mount. After the preliminary engine tests, the new monoplane without identification markings was prepared for its first flight. This happened on a bright, sunny Sunday morning in November 1926. A small group of company employees watched the historic event. After a takeoff run of 200 yards, roughly 183 meters, Openshaw lifted the aircraft into the sky to check how quickly it gained altitude. After 12 minutes, the pilot returned and began performing high-speed passes, sharp climbs, and steeper turns. The spectators were delighted. But after landing, it became clear that a great deal of work still lay ahead. The ailerons were too heavy and responded poorly to commands, the rudder was ineffective, and the elevator, on the contrary, was overly sensitive. In addition, during landing, the aircraft had an unpleasant tendency to bounce. Therefore, several weeks had to be spent fixing all these issues before the second flight. The rear sections of the wingtips were rounded, and larger ailerons with significant horn balance were installed. The elevator cord was reduced in a fairly simple way. A false trailing edge was added, and part of the uncovered framework, which had originally extended rearward, was removed. Then, a new elevator with a smaller cord was fitted, and to increase the fin area, a large plywood fairing was added to its upper section. However, the flight tests of the aircraft, which was named Wizard, were suddenly interrupted by a serious accident. An airlock stopped the engine immediately after Openshaw's takeoff in Yeovil. The pilot managed to land the machine on a narrow strip between new houses north of the aerodrome. But that strip was insufficient, and at high speed the Wizard struck a fence and overturned. Openshaw escaped with minor injuries, but the aircraft was badly damaged. Fortunately, Bruce had already evaluated the Wizard's characteristics and decided that the company would continue funding the project. Moreover, there was now an opportunity to introduce major changes and improvements to the design. The most important of these was the construction of an entirely new all-metal fuselage. As the power plant, they chose a 12-cylinder, V-type, water-cooled Rolls-Royce Falcon FXI engine, developing 490 horsepower from an early experimental series. The rebuilt aircraft was ready by November 1927. It was then that Westland's test pilot, Captain Louis Paget, made his first flight in the machine. At the same time, during the factory trials, the aircraft attracted the attention of the Air Ministry. In accordance with the specification requiring an all-metal aircraft with 2 machine guns to replace the Siskin and Gamecock fighters in metropolitan squadrons, aiming equipment was installed on the Wizard. Since up to that moment, the Wizard, the designation assigned by the Air Ministry, and had been a private venture, in November 1927 it received a military serial number. The new fuselage consisted of 2 parts, the forward and rear sections. The forward part resembled that of the first machine and was built from steel and duralumin tubes. The changes compared to the initial version included greater length. The forward fuselage now incorporated the cockpit. The metal skin was also extended. This time provisions were made for installing 2 fixed Vickers machine guns of .303-inch, 7.7 millimeter caliber firing forward, as well as for carrying 4 bombs weighing 20 pounds, roughly 9 kilograms each. The installation of the Falcon engine was designed to provide easy access and quick removal. Once the engine panels were removed, the entire mounting frame became fully exposed. A reduction gearbox with a ratio of 0.631:1 was fitted to the propeller shaft, allowing the use of a larger and therefore more efficient spinner-fitted propeller. The engine mount had a welded construction made as a single unit, and with the appropriate shock-absorbing materials, it allowed different engines to be installed. The engine had exhaust pipe stubs. For starting, a Huck starter connected to the propeller hub was used. It was inserted from the left side with a starting crank and engaged directly with the engine. A manual start using a starting magneto was also possible. Immediately behind the fireproof bulkhead was a 5-gallon, roughly 23-liter oil tank, connected to an oil radiator manufactured by Westland. The ribbed surface of the radiator was curved to follow the profile of the lower fuselage. Between it and the pilot's seat was a retractable radiator controlled from the cockpit with a handwheel. When fully retracted, it projected only 2 inches, roughly 51 millimeters from the fuselage, and also served as a very effective cockpit heater. The tail assembly was made entirely of duralumin. The stabilizer had 2 spars, and its angle of attack could be adjusted from +6 to -2 degrees. The rear spar moved 3 inches during this adjustment. On both sides, the stabilizer spars were connected to the lower fuselage spars by a pair of struts. The elevators were unbalanced, and their cord remained constant along the entire span. They were operated through compression rods, levers, cables, and intermediate shafts. A small triangular fin had a cutout for the rudder's horn balance. Although the company's drawings still showed horn balance along the fin line, the aircraft received a fin with proportions similar to the modified fin of the first machine. The main landing gear legs remained unchanged. The duralumin tail skid was cushioned by rubber blocks working in compression and featured a removable steel shoe. The skid was steerable as it was linked to the rudder bar and had a spring to absorb shocks. The reworked Wizard had no installed wiring, and in some places mock-ups of equipment were fitted to allow the machine to pass tests more quickly. Radio equipment was also not planned for the aircraft that the company was offering to the Royal Air Force. Accelerating with impressive climb performance to 190 miles per hour, Page found that the Wizard 1 was a fast aircraft. However, lateral control left much to be desired, so some time was spent adjusting the aileron horn balance until light and effective control was achieved. On the 29th of January 1928, Page flew the Wizard 1 to the establishment for official flight performance trials. The upper fuselage of the aircraft was painted bright blue, and the words, "The Wizard," were written in an elegant script on both sides. The notorious uneven surface of the airfield at Martlesham Heath became a real ordeal for the Wizard. At the end of February, the installed tail skid broke. In April, the telescopic strut of the tail skid failed during taxiing, and finally, in mid-May, the landing gear collapsed when the right-hand axle fittings failed during post-flight taxiing. This component, made of solid steel, carried the oil-damped shock strut, the half-axle, and the wire cross-bracing. During the accident, the whole section to which the half-axle and bracing were attached was torn off completely. Although the aircraft was moving slowly at the time, the damage proved enormous. Not only did the landing gear break, but the propeller snapped. The right-hand wingtip was damaged, the cabane struts fractured, and the fuselage was severely distorted. This led to the premature end of Wizard 1's trials. But on the 4th of June 1928, a mandatory incomplete interim report was submitted. The report stated that the machine flew at an all-up weight of 3,326 pounds, powered by an engine delivering 552 horsepower at 2,250 revolutions per minute in normal mode. Overall, the controls were good. Lateral control was fairly heavy but effective across the full speed range. Elevator control was usually light, but during high-speed turns it became quite heavy. At speeds close to the stall, directional control lost its effectiveness. Care was required during taxiing, and the landing run was found to be very long. The Wizard's maneuverability was considered worse than that of a biplane, and the fighter was rather sluggish when entering or recovering from turns. Although the bombing view was considered good, visibility for air combat, low-level flight, and landing was insufficient due to the long nose, the small gap between the fuselage and the wing center section, and the large center section struts. However, the report stated, "It is quite obvious that the modifications proposed by the contractor, combined with the installation of the new engine, will provide a substantial improvement in the forward view." The cockpit proved to be well laid out and comfortable. With the engine running, it was warm, but it became cold during prolonged gliding with the engine off. It was deemed necessary to enlarge the cockpit opening quite considerably so that the pilot could leave it quickly in an emergency. Flight performance tests were carried out at altitudes above 10,000 feet. The rate of climb at this height was 1,945 feet per minute, decreasing to 550 feet per minute at 20,000 feet. The calculated theoretical ceiling was 24,000 feet, and the calculated practical ceiling was 23,250 feet. The maximum true airspeed at 10,000 feet was 188 miles per hour, and at 20,000 feet it was 162 miles per hour. The landing speed was 72 miles per hour, and the landing run without wind was about 310 yards. The Wizard proved particularly convenient for the installation of equipment, and it was believed that it would cause no difficulties in maintenance within Royal Air Force squadrons. The results of the Wizard crash were, of course, disappointing, but the company Westland, in its report, recommended repairing the damaged fighter as soon as possible. The Air Ministry showed sufficient interest and issued a contract, and Wizard received a military serial number. According to the records, the aircraft returned to the test airfield on the 27th of June, and already on the 30th of June it appeared at the Royal Air Force display in Hendon as New Type Number 5. This identification number and military registration were applied to the sides of the fuselage at the rear. The Aeroplane Journal wrote, "From the public's point of view, it was, of course, the star of the single-seat fighter program. No official data regarding its performance were released, but reliable sources claim an excess of a speed of over 210 miles per hour. Judging by its speed against the wind and its exceptionally high rate of climb on takeoff, this is quite believable." On the 3rd of July, Wizard was returned to Yeovil. The fighter was to be rebuilt as Wizard 2 with a metal wing to take part in a competition that required a single-seat interceptor capable of reaching, in the shortest possible time, an enemy bomber flying at an altitude of 20,000 feet at a speed of 150 miles per hour. The fighter had to reach this altitude in less than 12 minutes and have a speed there of no less than 200 miles per hour. The main requirements were good combat visibility and maneuverability. Official trials were to provide comparative testing of biplanes and monoplanes with both low and high wing placements. The most noticeable feature of the new two-spar duralumin wing was that it now consisted of a center section and 2 outer panels. The center section was kept small to reduce obstruction to the pilot's view and was supported by 4 upper struts. It had a chord of only 4 feet 3 3/4 inches, and the cut out in the trailing edge was much larger. The wing panels had a slightly greater chord, 6 feet 6 inches, than Wizard 1, which had 6 feet 5 inches and not a reduced one, as some sources report. The total wingspan increased from 39 feet 6 inches to 40 feet. Another major change was the installation of a supercharged Rolls-Royce engine, for which mountings were prepared with a slight increase in radiator area. Work on Wizard 2, which retained its military serial number, continued into the early months of 1929. As of the 21st of February, it was still undergoing modifications in the company's experimental workshop. After the first flight and factory tests in September, it was sent to the test airfield to determine its flight characteristics. Test pilots quickly noticed vibrations in the tail assembly. Excessive wear was also found in the rods connecting the elevators to the intermediate shafts. The company arranged for the installation of contacts of increased diameter to eliminate the free play caused by loosened connections. Then the uneven surface of the airfield at Martlesham made itself felt once more. In early January 1930, the tail skid was destroyed during taxiing. The main tube of the shock absorber broke under tension. During repairs, Westland employees installed a reinforced transitional sleeve. An interim test airfield report was issued in February 1930. It mistakenly stated that the aircraft has not been altered in any degree compared with the appearance of Wizard 1, except that instead of the vertical strut previously used to connect the 2 wing panels in the plane of the fuselage symmetry, a center section has been installed. Unfortunately, there was a general deterioration in controllability. It was stated that controllability and maneuverability are not very good for aircraft of this class, and were quite moderate from an air combat perspective. The aircraft did not have a quick response to control inputs, and although stalling occurred at a low speed and the controls remained very effective during the stall, the Wizard's excessively low speed on approach could lead to a loss of height with a sudden hard impact on the ground. On the other hand, due to the very shallow glide angles, pilots tended to approach at too high a speed. Because of a slipping turn, the aircraft gained speed, and it was difficult for it to lose altitude. After touchdown, it maintained its speed on the ground for a long time. These factors made Wizard difficult both on approach and during the landing itself, especially on small airfields and during forced landings. The pilot still had a poor view of what was happening ahead. The long nose of the aircraft and the position of the wing blocked the view, especially when the machine was climbing. The pilot simply could not properly look forward and upward. Takeoff was fairly easy, but the aircraft immediately tried to turn to the right. So as soon as the pilot added throttle, he had to deflect the rudder to the left at once to maintain direction. On the ground, the machine taxied reasonably well, but due to the narrow landing gear, the center of gravity was too high. If a strong wind blew during taxiing, the aircraft became unstable and could tip over. The cockpit of the Wizard was the most uncomfortable of all. The pilot had to sit fully upright, and during long flights, his muscles cramped. The instruments in front of his eyes were positioned well. The switches, the fuel tank cocks, the fire extinguishers, and the machine guns were convenient to operate. But the radiator lever was located far too far behind, and it was difficult to reach. The wheel that adjusted the stabilizer angle of attack was just as hard to control. The seat did not adjust at all, a major mistake by the designers. and the rudder pedals turned out to be too short and uncomfortable. When the aircraft was tested for stability, it turned out that it held its nose-up and nose-down positions poorly. This made it a bad platform for machine gun firing. It handled the spin normally. Recovery was always trouble-free. But no dive tests were carried out at all because the elevators were split and that was considered dangerous. The final report stated that because of all these shortcomings, the Wizard did not meet the requirements of the technical specification. With an overall weight of 7,589 pounds, the aircraft reached a maximum speed of 197 miles per hour at an altitude of 49,213 feet and 194 miles per hour at an altitude of 65,617 feet. This was below the requirements. It climbed to 65,617 feet at a speed of 150 miles per hour in 14 minutes 52 seconds, almost 3 minutes longer than required by the task. It seems that after this, the official interest in the Wizard ended, although the aircraft continued to exist for some time. At the end of April, or at the beginning of May, it was discovered that the front support and the left landing gear strut joint were damaged. The rivet holes in the diagonal element that took the load during landing had stretched from compression. The Wizard was returned to Yeovil, where new brackets with corresponding modifications and reinforcement plates were installed, and some of the rivets were replaced with bolts. In March of 1931, the Wizard was sent again to the test base, most likely for armament tests by the 15th Squadron. After another return to Yeovil, the records state that on the 12th of November 1931, the aircraft was sent to the base again, but it seems that no further reports were made. Reg Butler, who from July of 1930 worked for 4 years as a fitter and aircraft mechanic in Martlesham, recalled that under the control of Flight Lieutenant Scroggs and Ernest Edward Pache, the Wizard spent most of its flying time in high-altitude equipment trials. He remembered that the engine, with its short exhaust pipes, produced a very characteristic crackling when throttled back. When the Wizard descended from altitude, Butler could always determine where it was simply by that sound. Butler believed that eventually the aircraft was sent for scrap.